Hello everyone, this is Chris Joseph and I'm going to help you guys out with the calculations for experiment number 10. So what we're going to do is we're going to go ahead and look at well number 3. In well number 3, what you guys watched was you saw zinc metal being placed in a lead nitrate solution. So what we're going to do is we're going to break these down into the half reactions. You're going to say that your metal is oxidized and you're going to say that the ion in solution is going to be reduced. What we're going to do is we're going to assume that every metal is going to go to the 2+ ion. Also to note that silver and hydrogen are just going to go to the 1+ ion. So let's go ahead and write our oxidation reaction down. So remember, an oxidation is losing electrons. So in this case, my zinc solid is going to become zinc 2+ ions, and we're going to make sure that we say it's aqueous plus 2 electrons. Now let's go ahead and write our reduction reaction down. In this case, we're looking at the metal ion in solution. It's going to gain 2 electrons and become lead solid. Now, what we have to do is we have to make sure that the number of electrons being created is the same number of electrons being consumed. And as you can see, there are 2 electrons being produced and 2 electrons being consumed. So in this case, we don't have to multiply any of these half reactions out. If the number of electrons are uneven, you have to multiply each half reaction by a number to make sure that the number of electrons being produced is the same number of electrons being consumed. Now what we can do is we can add our reactions together. Be sure to cross out the electrons on either side of the reaction and make sure that you keep all the states consistent. Now we can write this reaction as is because what we saw in the video was the reaction proceeds. You saw that the zinc was being coated by lead metal. Because this reaction took place, what you can do is you can comment on the activity of the metal. Since the metal placed in solution reacted, we can say that the metal is more active than the metal ion. So in this case, what we can write down is zinc has a greater activity than lead. Now let's take a look at the reaction that happened in well number 4. In this well, you put zinc in a magnesium nitrate solution. What you might have observed from the video is that there was no reaction that took place. So for your calculation section, when there's no reaction that takes place, you can simply write down no reaction. What this implies is the metal ion has a greater activity than the solid metal. Or in other words, what we can write down is that magnesium has a greater activity than zinc. Now you're going to do this for all the wells in this experiment. After you're done, you're going to get a whole bunch of these relationships. Once you get all these relationships, you want to string them together. So what we can say is that magnesium has a greater activity than zinc. But we know from well number 3 that zinc has a greater activity than lead. And so what we can do is we can combine our relationships together. You're going to complete the activity series for the whole suite of metals that we tested in this experiment. I hope that made sense, and Chem 122, stay safe.